Hi, we are Group 2. We are going to talk about Scikit Learn library in Python. And my name is Jim. And
Hi, Chi.
yeah, so I'm going to talk about what is Scikit-learn first. So what is Scikit-learn? Scikit-learn, and formerly Scikit-learn, is a free software machine learning library for the Python programming language. It features various like classifications, like regression, clustering algorithms, of course, including SVM to support vector machine and other algorithms as well. And scikit-learn is designed to interoperate with the Python numerical and scientific libraries like NumPy and SciPy. And then I'm going to talk about a little bit more overview and like history of scikit-learn. The scikit-learn project started as scikit-learn, a Google Summer of Code project. And its name stems from the notation that it is a Scikit SciPy toolkit as a separately developed from the SciPy. The original code basis was later rewritten by other developers, and in 2010, people from INRIA took leadership of the project and made the first public release on February 1st, 2010. So, like scikit-learn is all about machine learning in Python, so it gives a lot of features as well. So first one is simple and efficient tool for data mining and data analysis, as I said before. And second one is accessible to everybody and reusable in various contexts. And third one, it is built on NumPy and SciPy and Matplotlib, the visualization tool in Python. And also you can also use with Pandas, the data munging tool in Python. And fourth one, it is open source and commercially reusable. So it's really really good tool for people who just wanted to learn machine learning at first. So what can it do in data science? So it can do all of the data science things here because it offers classification, regression, clustering, and also dimensionality reduction and model selection and pre-processing. So scikit-learn is all about data science and machine learning. So you can do all about all of the data science projects with this scikit-learn. So it has like supervised learning as well. It also provides unsupervised learning as well, and dimension reduction like PCA, model selection, pre-processing. And so for a demo, we are going to use naive-based model to the text mining.
I will start with the example I will use here for for multinomial naive basis here, and the data set we get collected from Kaggle. It's a Kaggle competition, and it's working on sentiment analysis here. So first we need to reading the data, and as can be seen, the data is already labeled for each comment here inside the movie reviews, and there's a built-in function here inside the scikit-learn. It's called train and split. It can help us to split the data sets into training set and test set. Here we choose the 40% as our test set and the rest 60% as our training set. And then we want to check the data is to see how it looks and how it distributes. And here are the labels here from 0 to 4, and each labels has some kind of data. We can probably say the data is almost neutral. So it's good. We're gonna use this data set to do the next things. Then we want to do a vectorizer. Because all the data is text data, we need to separate it into numerical values. And here it's called vectorization. And the scikit-learn has several ways to build a vectorizer as you wish. You can do different vectorizer by setting different parameters here. And here we're gonna use the basics one with unigram and the count vectors to for our presentations here. And first we need to vectorize the training data, and then we set a rule to normalize the training data and use the same rule to our test data. And here how it looks like. After we do the vectorizer, we need to train a classifier. It's training the models. And the scikit-learn has their building functions called multinomial naive Bayes model, and we need to start the models and do it and want to know how it works. After we train the model, we want to see how the model works. And here we want to interpret the training models. Here we just want to show the most negative features here, and it's category 0, and so we choose the index 0 here for the based on the coefficients between each words here. Then we want to do a pretty look here, and want to show the most and the least positive features. And here, this is the least positive features here, and we can see it's almost the same as we plotted from the beginning. And here are the words with the positive features, and it's all numbers. Obviously, this means nothing. We need to clean them, but we don't need to do it here because it's not for scikit-learn. And now after we build the model, we want to see the accuracy rate on our model. So we call the score function inside scikit-learn, and it gives us a 60%. So it means we have a 60% accuracy rate for our models. Then we want to build a confusion matrix and see how exactly it is built to each category. And as can be seen here, there's 5 rows here and 5 columns here, and all this means from all that is labeled from 0 to 4. And so we want to make our the value on the diagonal line to maximizing. It means each label will be correctly predicted. But for now, we can see our model didn't work that fine. And the model for label 1, for example, at our label ones, this only 694 are correctly predicted, but all the rest are not correctly predicted. And so we want to do a classification report. You will see the exactly accuracy rate for each category. And then, as can be seen here, for label neutral, label 2, we have a 67% accuracy rate, and that's fine. But for all the other, it's just like 50 to 50. And for average, for the all-in-all average, we got a 59% accuracy rate. After we get into the accuracy rate, we want to see how many errors we made, some extreme errors, which means we originally a very positive example, but mistakenly predict as negative. And here we run the functions here. We see there's a 61 very positive record, but mistakenly predicted as very negative. This is some extreme example. And also, scikit-learn can do some cross validations to help us to choose models and find the best models we have. And here we just call the cross validations here, and it shows us it gives us a score that our model only runs a 56 accuracy rate. This is not good enough, but we are going here for introduction. If you guys want some more examples here, we can look into their websites. There are many examples in their website. For example, like linear regression, they can give you the whole idea of how it works in scikit-learn.